Okay, so we have two types of correlation, if you remember from the table, but I will focus on the Pearson's correlation. In Pearson's, or the correlation tells you not only the relationship and if they are related, but also the strength of that relationship. Like in here, we can have the Pearson correlation only between two variables, and we can just report that, only that, with its p-value. But what we usually see in a study is that we have a correlation matrix where we show the correlation not only between this and this, income from 2010 and income from 2011, but also between other variables. So this is something very common that we see in research. So we can interpret this. First, let me tell you how can we interpret the correlation. So the correlation always goes from -1 to +1, no more than that. And when we have -1 in the correlation, it means that our two variables are perfectly correlated, totally perfectly correlated, but the correlation is negative. So the more that I increase my variable, the less of this other variable I have. So for example, this is kind of the hours of sleep and tiredness. The more I sleep, the less tired I am, okay? So -1. This is, the other extreme is when it's perfectly correlated. The more time I sleep, the more, the happier I am, for example. So then more hours, happier, I increase it. And then when you have correlation coefficient 0, that means there is no correlation at all. So when you have something at 0 or close to 0, that means that there is no correlation. And then the other thing that you can interpret is that the closer that the number goes to 1, -1 or +1, the stronger the relationship. So as you can see, income from one year to the other is where you find the highest correlation. Income 2010 to 2011 is the highest correlation, but if you move 2 years, less correlation, less correlation. And here is the same. Income 2011 to 2012. It's very strong if you only move 1 year, but if you move more years, you lose correlation, right? That you can see that. Here in the table, it will always, we will always have this line because of course the income of the same year is going to relate perfectly with the income of the same year because it's the same date. So sometimes we don't even write this. We try to not write it. Then the correlation between this and 2011 is the same as this 2010 and 2011. So sometimes we can also exclude this. Like this, we exclude all of this and we end up with only this. Because with this, we show that income is actually correlated with income from previous years. It's not a secret, that is not such a contribution, but it's a nice example. And the more you move forward or backwards, the more years you have in between, less correlation strength, of course, because then the more you move, then it's more difficult to relate the two groups. But as you see, right, like this is a good example of correlation. And finally, correlation also has a p-value, and you will learn how to do it in quantitative math. But the thing is that, again, it should be below 0.05. And we have the two types of correlation as we have in here, Pearson and Spearman. But we're going to talk about that in quantitative lab. And finally, we had the regression. But for regression, I want to leave it for the quantitative lab because I think it's worth to talk about regression in specific when we actually practice. So regression is the last and most complete analysis, but we are going to focus quite a lot when we learn how to do it. And that's where I will explain a few things. So I think with that, we are done with this lecture about quantitative research. Number 2 is about the analysis. And I hope that it kind of gives you some light because there are some concepts that are very important too. I hope that you are not more confused than when you started watching the videos. Well, see you soon for the lecture.